On August 6, 1945, a nuclear bomb named Little Boy exploded over Hiroshima. The ground temperature at the epicenter of the nuclear blast instantly reached over 4,000 degrees Celsius. Residents standing nearby were vaporized in the blink of an eye, leaving behind charred black shadows on the ground as the only traces of their existence. Shortly after, a devastating shockwave swept through the city with an initial pressure of nearly 7 tons per square meter. The city center was flattened in an instant, with nearly 60,000 buildings reduced to rubble by the tremor. Approximately 80,000 lives were lost in the first few seconds of the explosion. Hiroshima was shattered to its core. 9 days later, World War II finally ended. Yet for many survivors, the disaster was just beginning. Massive amounts of nuclear radiation surged from the blast center, penetrating skin-damaging cells and destroying the basic structure of living tissue. Tens of thousands would die within days, weeks, or months. And diseases like infertility, tumors, cancer, leukemia, and cataracts would hang over the land like a nightmare for decades to come. After the Manhattan Project, J. Robert Oppenheimer said, "Now I am become death, the destroyer of worlds." This was no false modesty. On one hand, the nuclear bomb's enduring power did maintain long-term peace among major nations after World War II, while the application of nuclear radiation also opened new eras in medicine, industry, energy, and other fields. On the other hand, once the Pandora's box of nuclear power was opened, it was destined to spread like a plague among nations, and those who wield this terrifying power are ultimately human. Since they are human, there is no guarantee that every sword bearer will act rationally. Thus, nuclear accidents are not uncommon in today's world. What is remarkable is how different countries respond to them. We can't help but ask, what exactly is radiation? What is nuclear radiation? Which types of radiation affect our bodies? What specific hazards do they pose? And if radiation gets out of control, how high a price will humanity pay? As we gathered more and more information, this topic grew too long for a single episode. Therefore, we've divided the discussion of radiation into 2 parts. We hope you can give us a thumbs up to support our goal of releasing more episodes each month. After all, we should always have dreams. What if they come true? Wishing you all a happy day every day. On October 8, 1895, German physicist Wilhelm Röntgen discovered a new type of ray after noticing that well-preserved photographic plates in his lab kept getting accidentally exposed. This ray not only had penetrating power, but could also make fluorescent screens glow. Since nothing was known about this ray at the time, Röntgen named it with the mathematical symbol for the unknown X. On December 22, Röntgen took the first X-ray image in human history, a picture of his wife's hand. The following June, during his visit to Germany, Li Hongzhang became the first Chinese person to undergo an X-ray examination. The X-ray clearly showed a bullet embedded in his left cheek, a remnant from the assassination attempt by a Japanese attacker after he signed the Treaty of Shimonoseki. Just 1 month after the discovery of X-rays, Emil Grubb, a medical student in Chicago, wondered, if X-rays can pass through skin, could a high enough dose and concentrated beam burn away tumors that are inaccessible during surgery? Grubb tested this idea with a homemade X-ray machine. Though several cancer patients died during his experiments, he eventually managed to relieve some patients' cancer pain. This groundbreaking therapy became the prototype for what we now know as radiation therapy. Inspired by Röntgen's work, French physicist Henri Becquerel hypothesized, if X-rays can make fluorescent screens glow, might fluorescent materials themselves produce X-rays? His experiments yielded an unexpected result. Fluorescent materials had nothing to do with X-rays. But like how chance guided Fleming to penicillin, fortune smiled again during his trials. Becquerel noticed that photographic plates wrapped in black paper became exposed when placed next to a uranium-containing fluorescent substance. This meant the uranium salt was emitting some unknown radiation. Further experiments confirmed the existence of natural radioactivity. Inspired by Becquerel's findings, Marie and Pierre Curie discovered 2 new radioactive elements in 1898. Marie named polonium after her homeland Poland, and radium from the Latin word for radiation. The 3 scientists shared the 1903 Nobel Prize in Physics. Yet at the time, they had no idea that the radiation they studied was fundamentally different from Röntgen's X-rays. When hearing the word radiation, it's hard not to associate it with harm to the body. But counterintuitively, not all radiation is harmful. Broadly speaking, radiation refers to the spread of energy in the form of waves or particles. When you speak, you emit sound radiation. When you sunbathe, you receive solar radiation. Even your body generates thermal radiation. This is why thermal imaging night vision devices can detect you in the dark. The X-rays discovered by Röntgen belong to electromagnetic radiation, which transfers energy in the form of electromagnetic waves. Students with a physics background know that the higher the oscillation frequency of electromagnetic waves, the greater their energy. From low to high frequency, these primarily include radio waves, microwaves, infrared rays, visible light, ultraviolet rays, X-rays, and gamma rays. What Buckwell and the Curies discovered belongs to nuclear radiation, which originates from the atomic nucleus. Because some atomic nuclei are extremely unstable, they randomly emit particles and energy, hence the name nuclear radiation. Well-known examples include uranium-235 in atomic bombs, potassium-40 in bananas, and polonium-210 in cigarettes, all radioactive elements. In daily life, we are exposed to various forms of radiation every moment, which generally causes no major issue. However, when radiation energy is strong enough to knock electrons out of atoms or molecules, it becomes dangerous. Such radiation can damage the underlying DNA structure of life, potentially inducing cancer or even causing death. This is called ionizing radiation. All nuclear radiation is ionizing, while among electromagnetic radiation, only the highest energy X-rays, gamma rays, and the high energy portion of ultraviolet rays qualify as ionizing. Therefore, activities like looking at phone screens, commenting on this video, or even liking it, besides giving us great encouragement, because almost no radiation harm. Does exposure to ionizing radiation necessarily affect the body? Not necessarily. The human body can repair minor DNA damage on its own. Otherwise, the sun's ultraviolet rays would force us to work at night and rest during the day. However, even the most dedicated DNA repair enzymes have limits. If radiation levels are too high, they may make mistakes repairing DNA incorrectly, triggering cell mutations and cancer, or simply fail to keep up, leading to massive cell death. Ordinary cells can be replaced by stem cells, but if stem cells are depleted, the consequences are dire. So how much ionizing radiation can the human body withstand? China's basic standards for radiation protection and radiation safety stipulates that for workers, the average annual effective dose over 5 years must not exceed 20 millisieverts, and no single year should exceed 50 millisieverts. To put this in perspective, a banana emits about 0.000007778 millisieverts of radiation. 1 hour of air travel adds 0.005 millisieverts. A single X-ray exposes you to about 0.1 millisievert. A chest CT scan delivers 6 to 8 millisieverts. In short, unless you're extremely unlucky, the most significant artificial radiation source you're likely to encounter is a CT scan. This is why doctors sometimes use lead aprons to shield non-target areas during CT exam. By the way, magnetic resonance imaging uses radio waves and is completely safe. No need to worry about ionizing radiation, just about whether your wallet can handle the cost. But what happens if you're exposed to extremely high levels of ionizing radiation in a short time, or live long-term in a high radiation environment? Wilhelm Röntgen, who discovered X-rays, died of cancer after years of exposure to excessive X-ray. Marie Curie, a 2-time Nobel Prize winner, likely exhausted the hematopoietic stem cells in her bone marrow from prolonged contact with radioactive materials and died of aplastic anemia. Emil Grubb, who pioneered radiation therapy, developed tumors all over his body over 20 years later. Surgical removal of his palms, forearms, and upper lip left him disfigured, and he ultimately died of cancer. Early researchers often succumbed to radiation-induced leukemia and various cancers. It was their sacrifices that established today's safe radiation dosage standard. To avoid hindering scientific progress, neither Röntgen, Becquerel, nor the Curies patented their discovery. This created opportunities for capitalists. They launched Miss Fine beauty pageants, made posing for X-ray photos a fad, and shoe merchants used X-ray shoe fitting as a marketing stunt. exposing customers to radiation with each fitting. Some even promoted X-ray hair removal for women, which later caused skin pigmentation, infections, ulcers, and skin cancer in varying degrees. The commercialization of radioactive elements went even further. Uranium's naturally colorful minerals were used as colorants to make vibrant, slightly luminescent glass and tile, which adorned many bathrooms and kitchens. Then, radium's fluorescent properties made it popular for luminous paint. Young girls hired at watch factories were instructed to lick brush tips with their lips to sharpen them while applying radium-based paint to dials, ingesting large amounts of radioactive radium. Since radium metabolizes like calcium in the body, it accumulated in bones, causing internal radiation damage to surrounding tissue. These radium girls suffered severe radiation poisoning, with bones and organs riddled with damage. Radioactive products extended to radiant beauty cosmetics, red toys, underwear, condoms, and even Radithor, a tonic marketed to boost male vitality. The good news, radium's rarity made most products fraudulent. The bad news, wealthy consumers and unscrupulous merchants embraced the real thing. In October 1927, American industrialist Eben Byers injured his arm and was prescribed Radithor cure-all, claiming to treat more than 150 ailments, including hypertension and impotence. Convinced the tonic improved his health, Byers consumed 3 bottles daily, totaling over 1,400 bottles. Soon his teeth fell out, skin ulcerated, and immune system collapsed. By the time he suspected poisoning, his bones were riddled with radiation damage. He died at 41 kilograms with a disintegrating jawbone removed in a lead-lined coffin to prevent radiation leakage. The Wall Street Journal headline, "The radium water worked fine until his jaw fell off," marked the turning point for the radium tonic market. Here is the English translation of your article adapted to natural English expression and logical coherence while preserving the original narrative sequence. Although the development of nuclear health products has come to an end, research on nuclear radiation has never stopped. In 1938, German scientists Otto Hahn and Fritz Strassmann first discovered the phenomenon of nuclear fission while bombarding uranium with neutrons. Those who have studied atomic bomb development should understand what this means, for the basic principle of an atomic bomb is to use neutrons to strike uranium-235 or plutonium-239, causing them to fission and release multiple neutrons that then bombard other uranium nuclei, triggering a so-called chain reaction. This entire process releases enormous energy in an instant. Just 1 week after confirming that uranium nuclei could undergo fission, a sketch of an atomic bomb appeared on the blackboard in Oppenheimer's office, making the steady advancement of the Manhattan Project. On August 6, 1945, a uranium bomb named Little Boy fell on Hiroshima. 3 days later, a plutonium bomb named Fat Man was dropped on Nagasaki. On August 15, 1945, Japan announced unconditional surrender, becoming the only country ever to have suffered nuclear attack. Since then, nations like the Soviet Union, Britain, and France successively achieved nuclear test breakthroughs, and the world gradually entered an era of peace. Time magazine once featured Oppenheimer on its cover with a subtitle, "What we don't understand, we explain to each other," loosely translatable as "Let's talk things out." Whether others listen, however, depends on whether you possess genuine weapons of mass destruction. Iraq had none, yet the U.S. claimed it did, and thus launched an invasion of Iraq without UN authorization. Ukraine once had nuclear weapons but gave them up in exchange for security guarantees from the US, UK, and Russia. Today, it finds itself trapped in a quagmire of war. As Kuhn Ixusen once said, having a sword and choosing not to use it are two entirely different things. In October 1964, China's first atomic bomb successfully exploded at the Lunar nuclear test base. 2 years later, under humans' leadership, a hydrogen bomb, far more powerful than an atomic bomb, was successfully detonated. 60 years later, in September 2024, China's rocket force successfully launched an intercontinental ballistic missile carrying a training simulation warhead into relevant high seas areas of the Pacific Ocean. With the missile accurately hitting its predetermined target zone. After this demonstration of a missile capable of traveling tens of thousands of kilometers, a Pentagon spokesperson stated, "We did receive some advance notice about the intercontinental ballistic missile test, and we consider this a positive development." Is this reasonable? Absolutely. It is the most logical interpretation of Time magazine's. Let's talk things out. 2 months after China's missile test, Russia fired a new medium-range missile capable of carrying 6 nuclear warheads into Ukrainian territory. As the world debates whether a nuclear war might break out again, few remember that the two warring sides once joined forces in the largest campaign in human history to resist nuclear radiation, all to save the same country. That's all for this episode. If you found this content interesting or helpful, please follow us to learn more medical science knowledge.